Hello again. In this video we're going to look at a relationship between either two gears connected by a chain or two pulleys connected by a belt. Now if you have them spinning, they're spinning at completely different angular speeds, but think of two chains on a bike, and we'll talk about that momentarily. The chain moves at the same speed. So the chain is rarely representative of the linear speed for both of those gears, or the belt for both of those pulleys. Think of your car and you have that serpentine belt that connects your alternator to your air conditioner to all those other different things. The belt's moving at the same speed, but all those different size pulleys are spinning at different rates. So the relationship between them can be summarized in this one formula. Omega 1 R1 equals omega 2 R2, where the subscripts of 1 and 2 just represent the two different pulleys or gears. It doesn't matter which you assign which, just be consistent throughout your problem. Now, if we're following along in the handout on the pulleys and gears as well as the belt chain drive setups, if we look at number 1, it says in belt chain drive setups, two gears, pulleys traveling same linear speed, but radii are different if the angular speeds will be different, was the RPM of the smaller pulley. So in this case we're actually given that the larger pulley has a 4-inch radius, the smaller pulley has a 2-inch radius. The larger pulley spinning at 100 RPMs, how fast is the smaller pulley spinning? So it's actually a very easy formula to set up. There's 4 variables, but you have to be given 3 of the 4 to solve for the 4th. And in this case, we'll let 1 be that 4-inch pulley and let 2 be the 2-inch pulley. So the omega 1 R1 equals omega 2 R2. In this case, our omega 1 is 100 RPM. R1 is 4 inches. That equals omega 2, which we don't know. That's what we're solving for. And R2 is 2 inches. So when we're solving for one of these, on one half you're going to have both of them. You're just going to multiply those two numbers. On the half that you only have one quantity, you're going to end up dividing both sides by that quantity. So in this case, we're going to divide both sides by our 2 inches. So those cancel out there, and actually inches will cancel out there. So our end unit is going to be RPMs. So you see I'm going to take 100 times 4, which is 400. 400 divided by 2 gives us 200 RPMs. It's a very, very simple formula to use, and this is going to be a smaller piece of a much larger problem, that being a bicycle problem, that you're going to see in the next video. But one thing to keep in mind is that whenever you're using this formula, the 2 radii that you use have to be the radii of those gears or pulleys that are connected. No other radii can be used in that formula. But other than that, this is a simple formula, but again, it's going to be a part of a larger, more complex problem that you're going to see in the next video.